In this video, we are going to be talking about simplifying radicals. By the end of this video, you should be able to simplify any radical, no matter what the index may be. To start, we're going to be talking about different parts of the radical and then going through a few examples. So here we have a blank radical, so we're going to talk about the different parts. So when I am talking through these problems, you will understand what I am talking about. So here at the bottom, this entire thing is considered the radical. So the entire shape of it. So we have what's called the radical symbol, is what you guys are most used to calling the square root. Over here, a lot of times you don't see a number, and when you don't see a number, it's considered the number 2. This is called the index, and it can be anything. It could be 2, it could be 3, it could be 4. So this index is telling us what root we want to actually take of this whatever's inside, and what's inside. So let's say we have the number 24. This is called the radicand. So the goal of this is to get rid of any perfect squares, perfect cubes, etc., depending on whatever our index may be, where our radicand no longer has any of those numbers that can just move out. So let's do some examples. So we're going to start a little bit easy. We're going to start with the square root of 24, and we are going to simplify this. So a lot of you may in the past have learned to simplify radicals by making some tree diagram and then finding all the pieces that would match. Instead, the quicker way of simplifying radicals is trying to find the perfect square that is a factor of your radicand, or a perfect cube, depending again on whatever your index is. And anytime you don't see an index, that index is considered to be 2. So here I'm trying to find the perfect square that is a factor of 24. So I know that 4 times 6 gives me 24. So that means that this can actually be split up by saying this is the square root of 4 times the square root of 6. And we know what the square root of 4 is. The square root of 4 is just 2. So this radical simplified down to 2 square root of 6. So depending on what the number is inside, we may have to go and still simplify. So our goal is to try to find the largest perfect square, perfect cube, whatever it may be, that is inside of the radicand. So to help us do that, what I would suggest doing is off to the side somewhere, have a list of the perfect squares, perfect cubes, so forth and so on. So let's make a little chart. So we can list the perfect squares next to all of these. So this would be 1 squared is 1, 2 squared is 4, so forth and so on. So what this is going to do is it's going to help me find these numbers, these factors that will help me reduce the radicand. So I'm also going to list out perfect cubes, but I'm only going to go up to 6, because a lot of the times 6 is usually good enough to find out whatever number you're looking for. A lot of times when they're asking for a perfect cube, or the 4th root, or even the 6th root, they're going to be very small numbers that would have formed those perfect cubes. So this is still 1, 2 cubed is 8, 27, 64, 125, and 216. So again, you can keep on going, 343, so forth and so on. But a lot of times 216 is probably great where it is. So then let's see, for the 4th bar, we can go a little bit lower probably. So 1 to the 4th is 1. This is going to be 16. This is 81. You know what? I'm going to stop there at 81. We can do 4 to the 4th, which is 256. But again, these numbers are already starting to get really big, so more likely it won't keep going past that. All right, so now that I have this little chart off to the side, let's go and start tackling some other problems so you can kind of understand a little bit better. So this next problem. So we are looking at the fourth root of 128 into the 8. So for now, I'm just going to focus on the 128, and we'll come back to this into the 8th in a second. So I'm trying to find the perfect to the 4th power that is a factor of 128. So some number that would multiply to give me 128. So starting with the highest one, so over here we have 256. Well, 256 times whatever is not going to give me 128. So then I can go and I can look at 81. 81 times something isn't going to work. So now I'm looking at this 16. So if I try to think what times 16 is 128, hey, that one actually does work. So this is actually going to be the 4th root of 16 times the 4th root of 8, because 16 times 8 gives me that 128. And we know that the 4th root of 16 is going to be this 2 over here. So this is just going to be 2 times the 4th root of 8. And that is our final answer, because there's no other perfect to the 4th powers that go into 8 off of our chart. So I said we were going to hold off on the variable. So I want to kind of bring that back, and I want to just look at that variable piece all by itself. So we're going to start, and we're going to go back to this problem, and we're looking at the 4th root of n to the 8th power. So there's a couple ways of doing this. My favorite way is to actually turn this into a rational exponent instead. So I'm going to change this rational exponent. So this is going to change into n to the 8th divided by 4. So this top number is your power of whatever it came out from. So here's that 8. And then our denominator is whatever our index was. So we can then go and we can simplify this fraction. So we're going to actually simplify any fraction into a mixed fraction. So here, this actually comes out to be really nice, because 8 divided by 4 is actually an integer. 8 divided by 4 is 2. So this solution to this problem is just n squared. So if this had been some other number, so let's go and do a little sidebar. So let's say that this was the 4th root of n to the 13th power instead. So we can still go and we can turn this into the rational exponent. So this would be n to the 13 over 4. And I can simplify this mixed fraction. So this mixed fraction would go to n to the 3 times 1/4. So what this is kind of telling us is that we can bring out a whole n cubed, and I'm left with 1/4. So I'm left with a single power of 1 inside of, or as my radicand, and it's still an index of 4. So this is going to look like n cubed times the 4th root of n to the 1 power. Of course, you don't need to write the 1, but that's just showing you where that 1 is still coming from. So here was my leftover bit, and I still have that 4th power. So that is simplifying radicals. So what I want you guys to do, you are going to try these two problems. So pause the video, work these problems out, and then afterwards, let's see how well you did. So for the first one, you should have had the 6 16x times the square root of 2. And for the second one, you would have had 5y times the cubed root of 3y squared. If you didn't get those 2u tries, it is totally okay. We're going to have a lot of practice with simplifying radicals. It is going to be very important for this whole first semester. So just keep on practicing. I recommend going back to your practice or those 2u tries and try to find out where you went wrong, because the best way to learn is actually from your own mistakes. So again, it is okay to make mistakes. We're practicing right now. That's what's important.